My name is Sadadi, and I'm going to take you through today's session, which is focusing more on introducing you to GIS, to QGIS, to remote sensing, and some bit of overview to the land productivity analysis tools that you've learned about yesterday. I hope you're seeing my slides now. I'm trying to say, and
we can see your slides, Dr. Sadadi, and we can hear you clearly. Go ahead.
Maybe you can put on a presentation mode.
Yeah, that's what I'm asking, and I'm trying to sort that.
Okay.
Are you able to see them in presentation mode now?
Yeah.
Yes, we can. Yes, we can.
Fantastic. Thank you. As said, the main content of today's session is introducing you to GIS, and not only GIS, QGIS, as well as remote sensing, and then connecting that with the whole overall objective of this training, which is more of you to understand and get used to land productivity analysis tools. When we got the request from RIMCAD, I thought I need to come up with a few things that may be part of this course, and just as a list, I'll take you through an introduction to GIS and QGIS. Then there will be remote sensing aspect, where I'll introduce you to some bit of overview, because I understand that some of you are experts and some of you are beginners, and some of you are intermediate. So I'm trying to design a course that is a platform for all of you to either start your career with land productivity analysis, GIS as well, and for some of you who are experts, maybe just add more knowledge or act as a refresher. There are a list of materials that I've also added for you here, mostly the last one, which is the paper we published. It's a paper from the first phase of this project, and it's actually more of to do with the land productivity analysis tool we designed that you can actually access from QGIS and run. I've come up with the expectations that I expect you to get at the end of this course. By the end of this course, I expect you to understand what GIS and remote sensing is, what it can do, and how we used it in the context of land productivity assessment. I would also expect you to be able to describe what, GIS entails. I know some of you know all this, but for the beginners, I expect them to be able to say something about GIS, what it entails, what makes it becomes a functional working GIS. And I expect you to be able to identify areas within which GIS and remote sensing can be used to inform the land productivity assessment. Yesterday, Professor Majaliwa presented the brief on the model, and probably some of you would be wondering how you can introduce in remote sensing into the whole, soil analysis, and saying something about the productivity of soil, land degradation, and all that. So by this session, I will expect you at the end of the day be able to integrate this with the concepts of soil and land productivity. I also expect you to understand the different types of geographic data that you may need to use when you're undertaking soil and land productivity assessments. Of course, ask questions about your data sets, be able to get answer from the GIS and the remote sensing tools that will be available to you. And in this case, mainly we'll be talking about how you ask these questions and get the answers from your databases that are, accessed through the QGIS. At the end of this session, of course, I also expect you to apply systematic approaches to analyzing spatial data in the context of land productivity analysis and assessment. As might have been said earlier, the mode of delivery will be, we have this PowerPoint, which will introduce you to the concepts, explain them to you, and then we also have data sets that will be uploaded for you to access with like guides that you may use to be able to practice some of these things. And then we'll be able to have a panel and group discussions. There will be a session where we leave you the room to ask questions, and then we give you answers based on land productivity and or any other aspect to do with GIS and remote sensing. So we all know about how this project started. It was all about developing a land productivity analysis tool and methods, which we did. And then now we did it for 10 countries in Southern and Eastern Africa. And we all know which countries are these, and we mainly used Earth observation technologies. And then we integrated all these data sets, and we were able to develop a model which can be used to support and inform policy intervention processes at all regional level and national levels, so that you could be able to, get information towards land degradation mitigation. As said earlier on, the purpose of this training is also to empower you guys to be able to assess on your own land productivity using Earth observation tools. And then mainly you'll be using the QGIS platform that we developed, the plug-in for land productivity. And then at the end of the training, we also expect you to be able to model, land productivity using Earth observation data sets that may be available. We have used specific data sets, but the tool is designed in a way that you can actually use various data sets that may be available and specific to your country or the area of your interest. So a quick introduction to GIS. I know many of you might be knowing what GIS is. Pardon? Titus, is there something happening? I'm hearing background noise.
No, Daktari, you can go on.
Okay, thank you. So just to introduce you quickly to GIS, GIS is actually an acronym which means Geographic Information System. And it's a computerized database management system, which is used for capturing, storing, and allows you to be able to retrieve that information. You carry out analysis and display information that is defined by location. So this location can be Somalia, it can be Eritrea, it can be Djibouti, it can be Tanzania, any country where you are. As long as you have the database and you have your data stored in your database, you collected your data and you're able to, analyze and ask questions and be able to retrieve, but it will give you that information with its location, where it's coming from. And GIS makes it possible to integrate different kinds of data that may be, it can be a digital map, it can be an aerial photography, it can be satellite image, it can also be data collected on ground using GPS devices. And then you can associate this data with any other information that may not have the location aspect. For example, name, maybe height of something, maybe the quantity, any other information that may be useful. And in this case, you'll be talking about a specific land somewhere, then telling us about how rainfall is being recorded there, the weather changes, how the soils are. You collect your soil sample from different spots, and then you tag them to a location, and then you describe them. You bring in all the soil components, which then later you can retrieve and analyze and maybe relate it with your project goals. So that's what GIS helps you to do. So for you to be able to have this kind of computerized database, you need to have a number of components. And there are majorly 5 components of GIS that for GIS to run, you need to have them in place. So you need to have the software. So that's one of the components. I know many of you have ideas and have worked with different softwares, but GIS is not all about software. You need to have the software installed in a hardware, which is your computer, or it can be a mobile device. And the GIS software can also be a mobile-based GIS software. It can be desktop-based GIS software. It can also be server-based GIS software. So for you to be able to have a functional GIS, you need to have hardware and software all running together. But this is not enough. So you need to have data. And in this case, that's where Earth observation comes in. The satellite images, the data you collect from the field, you need to be able to collect this data, and then this data will go into the database, which you have designed using the software in your hardware. And of course, there are a number of methods, and that's where the land productivity tool that we've designed comes in. So there are a number of methods. They can be already embedded in the software, and they can also be specialized, like now the land productivity tool plugin that we have, which comes into the software, which gives you the methods, the do's and don'ts, for you to be able to say something about how productive your land is, how your soils are, and all that. And of course, once you improve on the skills you have, you get some knowledge from here today, you join these people. So it's not just any other person who will be there and doesn't know anything. They can have access to the GIS software data, but they will not be able to, work around with it. So you need to have the knowledge so that you join these guys up there, and then you'll be able to know which software you want to use. You'll be able to know which computer hardware that you need to adopt so that you run your software, or you decide whether you're using your mobile device, in that case, maybe a GPS. You decide what kind of data you're going to collect. That's why you have to get trained and have the knowledge and know how all these 5 parts run. You need to know the methods, the procedures, the do's, what is accurate and what is not accurate, what is needed, so you're able to run your whole GIS. Now we've been talking about GIS, we've been talking about computerized databases, describing, retrieving, data that is tagged to location. How about remote sensing? I think we have all been hearing remote sensing. What is it different from GIS? So I thought it is very vital for you to have a bit of an overview. Now, remote sensing is actually related to GIS in a way that it provides data for GIS. It's mainly the art and science of capturing that information. The information can be anywhere, and you just capture it without actually having a direct contact. And that's the concept which is very important for the land productivity, because you will be monitoring and assessing how productive land, or how land has been degraded in areas where you've never reached. So that's where you need some bit of technology that can help you get that information. However, there is also the concept of Earth observation. So what is the difference between Earth observation and remote sensing? Of course, Earth observation is more detailed. It's more of collecting information about the physical, chemical, and biological systems of the planet Earth. That's why it's called Earth observation. But actually, it is performed using the remote sensing tools. In this case, the focus would be more on the satellites. So therefore, the term EO is mostly used to refer to, satellite-based remote sensing of the Earth. And in this case, soil is part of or component of the earth that we are interested in. And therefore, we need to understand the concept of remote sensing. So remote sensing is comprised of two categories. We have what we call passive and active based remote sensing tools. The difference between the two is that the passive sensors actually they don't have their own energy. They rely on the solar illumination. So what happens is the sun illuminates the Earth's surface, and then the Earth responds by reflecting back, and the passive sensors now receive that reflectancy from the Earth's surface, and they're able to record that information and produce for us an image. While active sensors do not mind if there is sunlight, if it's not there, they have their own illumination, and they illuminate the Earth's surface, and they record the response of the Earth's surface in terms of reflectancy into the system. Now, for us to be able to move forward, we have to, decide which one we want to work with. I'll give you examples of these two. For example, we have what we call optical remote sensing sensors. So these are mainly satellites that use the solar illumination to be able to record. But on the other side, for example, Landsat, MODIS, these are all passive sensors. And then on the active sensor side, we have the LiDAR and radar systems that operate without relying on the solar energy and all that. So now, for us to be able to cover a whole ground area, a big area, we have to decide which one is more efficient and cost effective. And that's why we zero down onto passive sensors and select the ones that may be very useful so that we're able to collect very rich information. Now, within all these categories that we've talked about, there are also, again, 4 major attributes that may be very useful to decide on which remote sensing tool that we need to use to collect our information. And these 4 attributes are mainly the spatial resolution. You might be hearing about spatial resolution of different sensors. There is temporal resolution. And then of course, now the spatial resolution talks about how big, what does a pixel of an image mean on the Earth? Like if the pixel of an image is 30 meter by 30 meter, what does that mean? It means on ground, it's covering 30 meter by 30, 1 pixel on an image like this. So there are sensors that have very high spatial resolution, meaning that if it's 1 meter, it means 1 pixel you see on an image is representing 1 meter by 1 meter on ground. So probably you're able to see a tree or a building and describe that what I'm seeing on an image is a building. Meanwhile, there are those sensors which have low resolution, meaning that 1 pixel on the image that you get like this represents 250 meter by 250 meter. So this means that on that kind of image, you'll be able to see maybe a cluster of features. Say, you can say, I have seen a forest or I've seen a settlement, but you cannot describe whether you've seen a blue rooftop or a red rooftop. You cannot discriminate that on a low spatial resolution. So for example, Landsat is 30 meter by 30 meter. Like that image C, you're able to see, a cluster of, shades, just gray and black, white. But on a higher resolution, which is A, we can be able to say we are seeing a road, we are seeing a building, maybe we are seeing like some trees. Meanwhile, those with very low resolution, 250 by 250, we only see like huge squares, which are either distinct black, gray, or white. So that is what is comprised. So at this stage, you need to decide which sensor you're going to use. If you're going to be monitoring, say, the crops and seeing how they are doing and all that, you might want to use a higher resolution sensor. If you're going to be monitoring a wide area, things like soil, because soil doesn't vary so much, especially if you go into deeper layers. So you'll need probably a sensor that can cover a wide area, but the resolution may not be an issue to you. So you have to make that decision. Now, on the temporal resolution, we are talking about how frequent does the satellite give you the data. For example, if you are monitoring how maybe a building is changing over time, probably you want to see the rusting or maybe how much, okay, buildings may not be a quick example want to say, because it takes time for it to change, but there are some features. For example, if there is fire happening, you want to measure the extent. So you need a sensor that has very high temporal resolution. For example, when does it pass again to capture an image for a specific area? So that's the issue of time resolution. So for example, Landsat has 16-day revisit time. If it flew over a place, it will come back over the same place 16 days later. Meanwhile, MODIS is again another sensor with a higher temporal resolution. It can fly twice a day. It has two sensors on board. So one flies probably like early in the morning, another one in the afternoon. So you'll be able to monitor how your features are changing over time. So in this case, no sensor has, say, high spatial resolution and at the same time high temporal resolution. It's either one has higher spatial resolution and then the temporal resolution may not be as like it would be in the other one. So in this case, you have to, think and understand what you want to monitor using these sensors, and then you'll decide which one you'll take. Of course, there are four attributes we talked about. We need to know which attributes are those other two and how we arrived at the attributes we chose for this land productivity analysis project. So there is what we call spectral resolution. For example, Landsat. Now the spectral resolution is talking about the number of bands from which information is collected by these sensors. And these bands, the more bands, of course, you have, or the broader or narrow they are, it gives you a certain amount of information. And we also have what we call the radiometric resolution. And this is amount of energy information stored in an image. Like there are images that are 2-bit, 4-bit, 8-bit sensors. And now the difference between these is that the 2-bit image may only have 4 values. So that means it will cluster all features. For example, it will say this is all vegetation. So because there is reflectancy on a specific pixel, it may be closer to the other one, but because the radiometric resolution is very low, 2-bit, it will try to, merge the two that are close to each other. So you cannot differentiate between, say, broadleaf or coniferous forest. It will classify all of them under one. And then for maybe bare soil or land with maybe dry vegetation, that will be all combined in one. So you cannot classify those. Meanwhile, like a sensor with higher radiometric resolution will have like 8-bit with up to 255 values. So you can split between the features. You can say, okay, this is bare soil, this is maybe vegetation but dried, maybe vegetation that's nearing the maturity, or fresh vegetation starting. And you are able to classify maybe different sets of forest. Maybe this is closed canopy or open canopy. You can split them because you have a variety of information you are dealing with. So in this case, for us, for the land productivity analysis program, we had to look at all these 4 attributes and then decided which sensor can actually give us information, which is very vital to arrive at, the best productivity analysis, aspects of our project. So, we chose basically a group of, sensors. Not only one. We worked with different data sets. We used MODIS. MODIS gives us very high temporal resolution, and then of course high radiometric resolution, and of course with high spectral resolution. So we took it up as one of our main sensors from which we collected data, which we used in our land productivity analysis tool. Now, from that, just a bit more on the QGIS. QGIS is now forming the component of software. We have talked about remote sensing and GIS, which goes to the people component. So we have knowledge. Until now, we know we can use GIS. We can build a database in a hardware, and we use remote sensing tools and methods. So we have hardware, methods, and then, of course, we are enlightened now a little more about the software. So as said, there are so many softwares you can use for doing these things. But of course, we had to zero down on QGIS because it's one of softwares that is freely available. You don't have to buy a license. You just get internet and you download. You're able to store it. It gives you opportunity to do both GIS and remote sensing. So you're able to work with your GIS data sets, which may be vector data, and then be able to integrate with, satellite images, be able to design tools that you can use in as a plug-in, and be able to do your own analysis. GIS was actually one of projects which later on turned to be like a GIS software. That's around year 2002. It runs basically on most of the, computers and all operating systems, especially Windows and OS. And you can have a number of toolkits. You'll be able to, design your own, codes and be able to run them within the software. It's also a user-friendly software and supports, of course, as said earlier on, both raster, which is an image, or aerial photography, and data from aerial, photographs. You can manipulate them and work within QGIS. So this is the model that we developed in this project. Yesterday, Professor introduced you to this. Of course, we have a number of data sets ranging from like agroecological zones. We generated NDVI data, rainfall. We also took up land cover or land use data for these countries. Then we used digital elevation models. We looked for data related to, different land uses and then put them in the model. We ran these models and then assessed the relationship between the various data sets and then used that information to develop this land productivity. More on this was already explained by Professor yesterday. And then it's actually the tool. That's how the tool runs and be able to get the data. And the focus here is you get your remote sensing data, and then you can get the indices, or you just run the images. The model will calculate for you these indices based on how you put them in the software, and you'll be able to generate an output, which is your land productivity information. So we were able to generate land productivity for the 10 countries and also assess soil productivity. As you can see on the first map, we can already know which areas are highly productive and those that are with low productivity. This is all based on the datasets, various datasets we used, and the main Earth observation datasets we used were from MODIS. We also used Globe Cover 2009 products. We also obtained datasets from FAO, especially regarding the soils. We used SRTM digital elevation models to optimize our results. On the right-hand side is the soil productivity analysis result. So you can already see the areas with the high and low productivity, as well as moderate. And then you can, from the model, you then plan how you go with your activities in terms of those that rely on these results. The tool requires you to prepare data, of course. In this training, we have done that already for you. So the data sets will be uploaded, and you'll be able to download them and play around. So we also give you more guidelines here on how you'll be able to do that and be able to produce, your own maps using QGIS. You'll get this installer, or you just use this link to be able to download this current version. I think this was some time back, but the current version may be higher than this, but still you're able to download it using this this link, and then you just install it. QGIS, as said, is very simple to work with. You don't have to hassle, you just download, run it, and you're able to install it, and then you'll be able to start working with it. There are a couple of steps that we have put for you here on these slides. You'll be able to launch it just like any other software that you can work with. You can configure the plugins, you can download, you'll be able to, use existing Earth observation dataset tools like GDAL to process huge datasets. You can configure toolbars. So this is more or less like step-by-step guide that you can follow. Of course, this is the interface where you'll be working, and I think it's quite easy. Once you launch the software, you'll be able to see this page. You can now manipulate the tools. As said, this is more or less like a guide. I think you'll go through this last slides by yourself with the data sets that are provided. You'll be having a number of steps that will help you add GIS data, mainly vector data. You'll be able to, add SEP files. Most commonly, we call them SEP files. You then, manipulate them. You can see your layers. You can index overlay, and then you can play around just using these step-by-step guides. You can also explore features. For example, if you want to know where specific sites are, for example, if you are working with the regions, maybe a region is very suitable for certain crop and you want to select it, you'll be able to identify that using the tools that will be available for you. You can view the attribute table and be able to know your data set more and explore, be able to identify features, areas of interest to you. More to that, just as I said, you can select your regions of your interest and then work around them. So this is more or less like a step-by-step guide, which you can follow later to be able to produce your results, to carry out first your analysis and then visualize your results. Of course, you can also add, as said, like remotely sensed images. It can be elevation data, it can be a raw satellite image, which you can add, and then you'll be able to view, explore, and then see which analysis tools do you want to run around the data and be able to generate results. be able to, you know, classify your images and then produce maps that you can work around with, be able to run calculations on your real raster so that you're able to identify maybe areas with, say, high productivity, areas with low productivity, areas that are receiving more rainfall, depending on the data sets that you're working with. Also within the QGIS, once you finish your analyses, you'll be able to produce a map that shows the results of your analysis. For example, the maps that we've shown there. Once we finished all the analysis, we get the results, but the results are not yet ready. You need to add like the elements, the scale, the, you know, the grids, be able to, you know, demonstrate what you've analyzed, the results you found, so that somebody who doesn't know the system is able to read the map and get information. So these are all more steps for you, which you'll be following, I think, after here, with the data that is provided, and be able to produce map that may be useful to you. Thank you. So I think from here, I don't know if you allow me, maybe I can just open for you the interface of QGIS, maybe show you a few aspects of this last few slides, which are more giving you directives on what to do, and maybe add some of the data sets that we have given you so that you'll be able to work with. I have launched this page. So what you have to do is you go to, if you are running on Windows 11, things have changed a little bit, so it has made it easy for us. So you just go to the search button and then you can type QGIS. So it will bring for you all the apps that you have installed. So what I gave you in the guide is more on how you can start from zero, but of course, depending on the Windows you're running, the other option might be very long. So like I'm running on Windows 11, so I can just search on the search tab. So you just put QGIS and you'll be able to click, and then it will load for you the software. And once it is done, this will be the first page that you'll see. And then I want to dock my, because I can't dock the Zoom tools, it's kind of hiding. So I've decided to minimize so that I'm able to see of course the screen, the full screen for the QGIS software. As I said, once you launch your QGIS, it will bring for you this window, and on this window it will tell you you're starting from a new project which doesn't have a name. It gives you that default name as untitled project. And then once you are here, you'll be able to either open an existing project. You'll have your menu bar here, which leads you where all you find your tools that you're going to work with. But there are also other tools that are by default brought for you here so that you are able to manipulate and work with. But because we are starting as a beginner, I'm going to just demonstrate to you where you can start. So you'll start from project, and in this case, you start a new project. And once you start a new project, you'll be able to get this blank page. So the first thing you do is, because we have given you data sets, and those data sets inside the software, they are referred to as layers. So you can go under layer and say you add a layer. And once you click you add layer, there are a number of other tools that you work around with. So depending on the kind of layer you have what we call vector layers. We also have raster layers. Your satellite images will be under raster layer. Other shape files like maybe boundaries, point data where you've done your field observations will be mostly be under vector layer. For example, we can open vector layer for Uganda. Sorry, this thing is hiding. So you already know where you've saved your data sets. They're either in a directory or a database, or you're accessing them from online. And in our case, we have saved them in a file within the computer. So then once you choose where you've saved your data sets from, you'll be able to, specify the source. And in our case, we go to our folder where we've saved. And in my case, I have saved it on desktop in a folder created as Regional Center for Mapping, Training 2023, and then Spatial Data. So it's already opened for me. So maybe I want to see the districts. So you look for the save file for districts. So in that case, we get our save file for districts and we open and we say add. And once you click add, the software will add for your districts. And for the case of remote sensing, if you want an image data, and then you'll go to raster. And in this case, our raster is saved in the same folder where we're working with. And I think you also have access to that same folder. So you browse, and in this case, let's pick, for example, elevation. So elevation is a raster in a raster format. It's like an image. So all the other images would open just like the way this opens. And then you'll add. So once you add, you'll see your elevation here, data for Uganda. So you're able to get values, you're able to play around, you're able to identify. For example, if we click here, we will know that the elevation here is 177 meters above sea level. So you're able to click somewhere, you manipulate using all these tools. You can zoom in, you can zoom out, you can zoom to full extent, just using the buttons available on the tools bar for you here. Now, you can also create maps. As you can see towards the end of my slides, I showed you how you can create maps, but of course, you'll play around with that. I just sort of want to show you the land productivity analysis tool that we developed in this project. So there are a number of plugins that you'll need to work with within QGIS. All of them will be under your plugins here. You just click, you're either going to write your own code, or you already have the plugins done for you. You just need to install. So you click under plugins, so it will open for you this window. So these are all plugins, like most of them that I've already installed here. For our case, we have the land productivity analysis tool. If you don't have it installed here, you can always, install from either a file that you're having or you're going to download. But in our case, if it's not installed, you'll have to, you search the name here, you can search the name. And in our case, we have already done they installed it here, the land productivity analysis tool. So you just search for it. And then so here we are. So you click on it. So it's already installed. I think you'll get time and play around with it. Once it is installed, you can now load your images and be able to run and produce a land productivity analysis result for your specific area of interest.